Hi everyone. Well, it's time to review for test 3. So I'm just going to go through most of the practice test. So this is number 1. We want to find the restricted values of the rational expressions. Let's start with part A, 3x plus 6 over 6x minus 4. Okay, so how do you find the restricted values? So remember, for the restricted values, we only care about the denominator. So we take the denominator, 6x minus 4, and set it equal to 0. Okay, and then we solve that equation. So to solve it, and this is just a pretty straightforward linear equation, I'm just going to add the 4 to both sides, giving me 6x equals 4, and then divide both sides by 6, right? And so that gives me x equals 4 over 6, which of course reduces or simplifies, right, to 2 over 3. Just cancel the 2's, right? So that's the restricted value, and that's all there is to it, right? Don't get confused with domain, which we talked about more recently. The domain is everything else, everything except the 2 over 3, right? In particular, it's the set or collection of all values of x that are not equal to 2 over 3. And if you remember, we usually write this in interval notation. We want everything less than 2/3, so from negative infinity to 2/3, or, so union, everything from 2/3 to infinity. Okay, so that would be the domain using interval notation. Just as a reminder, although that's not the answer to the question. The answer here is 2/3. But this is if they were asking for the domain, which again is everything less than 2/3 or everything bigger than 2/3. Okay, so so part B, we have 4x squared minus x minus 3 over 4x squared minus 3x minus 1. And again, we want to find the restricted values. So again, we only care about the denominator. We set it equal to 0, and then we solve this equation. Right? And now this is a quadratic equation, so this goes back to chapter 6, where we were solving quadratic equations. The only way we know how to solve this at this point is to factor. Right? So we have to factor the left side. Right? And, well, I mean, some of you know the quadratic formula, and that's fine. You can use that. But at this point, most of you don't, so we're going to just factor it. And let's see, can we do 4x and 1? So I'm taking a shortcut here, right? Because these have to be 1's. And then it's just 4 minus 1 is 3. We want negative 3, right? So we want negative 4 plus 1. Right? So let's check that this works. We get 4x squared minus 4x plus x is negative 3x, and 1 times negative 1 is negative 1. Okay. So again, I did this using the shortcut. If you have to use the AC method, that's fine too. Takes a little longer, but you'll get there. Right? So we factored the left side successfully, but we still have to set it equal to 0. And so that just means we set each factor equal to 0. So we get two solutions here, right? We get negative 1 over 4 or positive 1. Right? So, yep, this rational expression has two restricted values, negative 1/4, that should be an x, and x equals 1. Okay, again, nothing to do with domain. The domain is everything else. So we'll get to domain later again. All right, so part C and D are very similar. Let's do D very quickly. So here we have 9x minus 3 over 8x squared minus 2x minus 3. Again, we're looking for the restricted values, just to remind you. And it's done the same way, right? You just take the denominator and set it equal to 0 and solve that equation. Again, we're going to factor it. If you want to use the quadratic formula, if you know what that is, you could do it that way, but let's do it the way we all know how to do it, by factoring. So again, we have to factor the left side, 8x squared minus 2x minus 3. And this time I'm not going to use the shortcut because it might take a while to figure that out. So I'm just going to go ahead and use the AC method, as I probably should have in the previous one. So here, A is 8, B is negative 2, and C is negative 3. So A times C is 8 times negative 3, which is negative 24. And so now we have to find two numbers whose product is negative 24 and whose sum is B, negative 2. Okay, so we go down the list. Negative 24 times 1 is negative 24. Negative 24 plus 1 is negative 23. So that's no match. That's not negative 2. So let's try negative 12 times 2. That's still negative 24. Negative 12 plus 2 is negative 10. Still no match. Let's try negative 12 times 3. What am I doing? We did negative 12 times 2. Negative 12 times 3 doesn't work. It's negative 8 times 3, right, is negative 24. And negative 8 plus 3 is negative 5, not negative 2. Right. Right. So the next one would be negative 6 times 4 is negative 24. And negative 6 plus 4 is indeed negative 2. Okay. So there's our match, right? So now we know we split up the middle term as negative 6x plus 4x, and then factor by grouping, right? Split it up. From the first two terms, we can factor out a 2 and an x, and that gets us 4x minus 3. And from the last two terms, the GCF is 1, so I'll factor out the 1. And so that means we factor out the 4x minus 3, and that multiplies the 2x plus 1. Okay, so there we go. We factored the left side as 4x minus 3 times 2x plus 1. Okay, so yeah, a lot of work using the AC method. And again, it's right. There's no trick question here. This was bound to factor. If you find that it's not factorable, then that doesn't mean there are no restricted values. It just means that they're not nice numbers. They're not rational numbers. But that's not going to happen here. So let's not worry about that. So the only thing left to do is to solve these two linear equations. And you can do that in your sleep, right? You get 3 over 4 and negative 1/2. So again, those are the two restricted values here. You can write it as a set. I think Connect Math prefers it as a set. 3/4 and negative 1/2. So again, two restricted values for part D. Okay, so that's restricted values. I hope that's okay. Okay, that brings us to number 2. Now we want to simplify rational expressions. Right? So remember what simplify means when it comes to rational expressions. It's just 2 steps, right? It's factor and cancel. Right? We factor everything, numerator and denominator, completely. So the numerator is 5. 5 is a prime number, right? So there's really no way to factor it other than 1 times 5, or 5 times 1. In fact, let's do it that way, 5 times 1. Right? But the denominator, 5a plus 20, we have a common factor of 5, right? This is 5 times a plus 5 times 4. right? So the 5 is your common factor, and when you factor it out, you're left with a plus 4. Okay, so that's the factoring part. Now we cancel. What are we canceling? Any factor that's common to the numerator and denominator. In this case, it's the factor of 5. So we can cancel the 5, and we're left with 1 over a plus 4. Okay, so this is why I actually wrote 5 as 5 times 1. Usually we don't write the 1, but you can see if I didn't write it, a lot of people get confused with what goes on top. Right? It's not 0, right? It's this invisible 1 here. So that's why I wrote the 1 when usually it's not necessary. But here it is, right? You can't just write nothing over a plus 4, because it's not nothing. It's always a 1. That's multiplying, anything. Okay, so that should have been pretty routine. Let's go on to part B, which is not quite as simple. So the hard part here, of course, is to factor everything. And I'm going to do the denominator first because it's a little bit easier, right, because a is 1 here. And we just need two numbers that multiply to 16 and add to 8. Okay, so there's a couple ways of doing this, right? You can do 16 times 1, but 16 plus 1 is 17. Right, so 1 plus 16 is 17. That doesn't add up to 8. 2 times 8 is 16, but 2 plus 8 is 10, and that's still not 8. It's not divisible by 3, but you can divide by 4, right? 4 times 4 is 16, and 4 plus 4 is 8, right? So this should factor as x plus 4 times x plus 4. And in that sense, it's also a perfect square, right? It's x plus 4 squared. And that's the way you should write it. I'm going to leave it as x plus 4 times x plus 4 here, right? Right. So now let's go to the numerator. The numerator is 3x squared plus 14x plus 8. So AC method works as usual here. A times c is 3 times 8, which is 24. So what two numbers multiply to 24 and add to the middle number here, which is 14? So I'll remind you of that. 14. There we go. All right. Right, so it's not 1 times 24. 1 plus 24 is 25. You can do 2 times 12 is 24. And 2 plus 12 is 14. So there we go, right? So we split up the middle term, the 14x, right, as 2x plus 12x, or 12x plus 2x, right? And then you factor by grouping. So the first two terms you take out an x, leaving you with 3x plus 2. And the last two terms you can take out a 4, also leaving you with 3x plus 2. So we're going to factor out the 3x plus 2, which multiplies x plus 4. So the numerator is 3x plus 2 times x plus 4. Right, everyone okay so far? So that's the factoring part. Everything I think is factored completely, and now we cancel. Our common factor here is the x plus 4. So we can cancel those, leaving us with a numerator of 3x plus 2 and a denominator of x plus 4. And we are done. Right, nothing else to cancel. Please do not cancel the x's. That would be very bad. Right? I mean, we didn't cancel the 5s in part A, right? Because if you do that and you have a plus 20 in the denominator, well, that's just wrong, right? You cannot cancel terms. You can only cancel factors. All right, let's do part C as well. Okay, so here's part C. We want to simplify x cubed minus 3x squared minus 4x plus 12. Oops, typo here. I didn't write it down correctly. So be careful, write everything down correctly here. So yeah, x cubed minus 3x squared minus 4x plus 12. All over x squared minus x minus 6. So I think I got everything right here now. Okay, so simplify. Remember, factor and cancel. So we cannot cancel anything yet. Please do not cancel x squared. They're terms, not factors. Yep, so you have to factor everything first. And again, that's just, how good you are at factoring. Let's do the numerator first. So GCF is 1. Always check for the GCF. In this case, it's 1. So because we have 4 terms, again, we're going to factor by grouping. It's already set up that way. So from the first 2 terms, we factor out x squared. We get x minus 3. From the last 2 terms, we factor out a negative 4. And again, we get x minus 3. So when we factor out the x minus 3, we get x squared minus 4. Okay. But hang on, let's not write that yet because we're not done yet. We're not factored completely. X squared minus 4, we can factor again. Right? This is a squared minus b squared. So you factor as a minus b times a plus b. Okay, now it's factored completely. Right? So that's the numerator, x minus 3 times x minus 2 times x plus 2. Right? Again, if you leave it like this, you're not factored completely. And in this case, that's going to get you in trouble because, well, you see when we factor the denominator, it's not going to work out entirely here, right? So you got to factor completely here. Okay, now let's do the denominator, x squared minus x minus 6. And I won't bore you with the details here because this should be pretty easy at this point. It's not going to be negative 6 and 1, right? So it's got to be negative 3 and 2. Right, so I hope you can get that pretty quickly here. If not, you can still use the AC method, right? That always works. It's just a little bit more work, right? So there's really only 2 guesses here, negative 6 and 1, and negative 3 plus 2. So we're looking for negative 1. Oops, there's a negative 1 there, instead of negative 5. All right, so that's the denominator, right? X minus 3 times x plus 2. All right, so and I think we're factored completely. Now comes the fun part. Now we cancel, right? So everything is multiplying here. There's no adding or subtracting, right? So the factors we can cancel are the x plus 3, right? And the x plus 2. It's the same in the numerator and denominator, right? So what are we left with? Well, we're left with x minus 2 in the numerator. And in the denominator, right, again, it's not a 0. It's an invisible 1. So x minus 2 over 1. But, of course, anything divided by 1 is just itself. So this is really just x minus 2. So all this complicated mess here, all that really is, it's just x minus 2. So this is what we mean by simplify. Take something very complicated and turn it into something a little bit simpler. Okay, so that's part C. And let's do part D because I know that's going to be a difficult one. Okay, so this is number 2, part D. Part D. So 12x cubed y to the 5th plus 48x squared y to the 6th plus 36x y to the 7th all over 3x to the 4th y minus 3x squared y cubed. Yeah, so again, this is not, probably doesn't look like an easy one because in this case we have both x's and y's, but it's still done the same way, right? We want to factor and cancel. So let's start with the numerator here. The numerator, 12x cubed y to the 5th plus 48x squared y to the 6th plus 36xy to the 7th. The GCF is not 1. The GCF is going to be 12 times x times y to the 5th. Okay, so let's factor out the GCF. When you divide, you just get, let's see, x squared plus 4xy plus 3y squared. Okay, and again, that's just the numerator. And I don't think we're still done yet. We can factor the numerator here. I'll leave the GCF, 12xy to the 5th. So we know x times x is x squared. And we know 3y squared is probably just 3y times y. And they're all pluses. So I think that's how you factor this trinomial here as the product of these two binomials. Okay. So yeah, there's really no choice. I mean, the only choice is where to put the 3. Yeah, we could have put the 3 over here. Doesn't matter, right? So either way, I think we're factored completely. The numerator is 12xy to the 5th times x plus y times x plus 3y, and then all over what? Okay, so now we look at the denominator. And again, I see a 3 here and a 3 here, so the GCF is 3. But I also see an x to the 4th and x squared. So I take out the lowest power, x squared, and the lowest power of y is y to the 1. So that's the GCF. And when we factor that out, we're left with x squared minus y squared, or a squared minus b squared, right? So that's the usual a minus b times a plus b. In this case, x minus y times x plus y. So that's how to factor, the denominator. And I think there we're factored completely as well. And I keep writing it twice, so I'll just leave that up here. Right? And so I think with everything factored completely, now we can just cancel. So what cancels here? Well, x plus y and x plus y, right? So those go away. And then 12 divided by 3, of course, is just 4. And x divided by x squared is 1 over x. So we have an x in the denominator. And then finally, y to the 5th divided by y is just y to the 4th. And that's in the numerator. And then x plus 3y, that's still in the numerator. And x minus y is still in the denominator. Now I realize I didn't need a really big fraction here, so I can erase that. And I think that's it, right? So this is the answer to part D. So not as bad as it looks. It's mostly just factoring out, again, the GCF, the greatest common factor, right? And then factoring this trinomial, and then factoring the difference of squares. Okay, so that's simplifying. Okay, so number 3, we want to multiply and simplify the product of these two fractions, right? 27a squared b to the 4th over 16x cubed y times 20x to the 4th y cubed over 9a squared b to the 7th. Okay, so multiply and simplify, right? Usually you simplify first, right? So that means we want to factor and cancel. So as far as factoring goes, there's really nothing much to do here except the numbers. For example, 27, right, is just 9 times 3, or 3 times 3 times 3. And yes, I should probably write this as 3 to the 3. But, right, because we might want to cancel some of the 3's, I'm going to write it out as a product here, right? I'm not going to do that with a squared, though, right? We could write this as a times a, but that gets to be a little bit cumbersome. So I'll leave it as a squared b to the 4th, right? And then the denominator, 16, is 4 times 4, or 2 times 2 times 2 times 2, right? 2 to the 4th, times x cubed times y. And then 20 is 4 times 5, and 4 is 2 times 2. So 2 times 2 times 5, x to the 4th, y cubed, all over 9, which is 3 times 3, a squared b to the 7th. So remember, when you multiply straight across. So now that everything is factored, right, let's see, I'll put the 2's first, so 2 times 2, and then the 3's. So 3 times 3 times 3. Then the 5. Don't forget the 5. And then we can do the variables here, right? A squared, b to the 4, x to the 4, y to the 3. In the denominator, I have 4 2's, right? So 2 times 2 times 2 times 2, and then the 2 3's. So those are the numbers. And then the variables, right? So I'll put the a squared first, b to the 7, x to the 3, and then y. Okay, so cancel time, right? Now we just cancel all the common factors. We cancel the 2's here, these 2's. We can cancel these 3's and these 3's. So I think that's it. Oh, we can also cancel a squared because it's the same in the numerator and denominator. Everything else, right, the exponents just subtract here, right? So what do we have left in the numerator? We have a 3 times 5. 3 times 5 is 15. Right? And in the denominator, we have 2 times 2, which is just 4. All right. So what's the power of b? Right? B to the 4 over b to the 7. If you remember the rules for exponents, you subtract. So this is b to the 4 minus 7. Right? For the x's, it's going to be x to the power 4 minus 3. And then for the y's, 3 minus 1, right? It's always that invisible 1. So we're still left with 15, b to the negative 3, x to the 1, y to the 2, all over 4. Okay. One last thing to do, remember you're not allowed to have negative exponents. So to make it a positive exponent, we'll just bring it downstairs. So we'll make it b to the positive 3 in the denominator. Right, and we could have done that originally by subtracting 7 minus 4, right? But it's 1 over b to the 7 minus 4, which is 1 over b to the 3. Again, just illustrating that the b cubed is in the denominator, not the numerator. But that's it. That's as far as we can go, right? 15xy squared over 4b cubed. All right, so that's part A. Part B. Okay, 3b. Multiply and simplify. We've got 3x squared plus 6. Oh, wait a minute. Typo. Let me fix this. Okay. So yeah, the first numerator here is 3x squared plus 12x, not 6x. I don't know what happened there. Over 6x cubed plus 24x squared. Times, the second fraction is 4x squared minus 8x minus 12 over x squared minus 9. Okay, so again, make sure you write down the problem correctly. I think I did. Right, and we're not going to multiply, we're not going to multiply the numerators yet, right? This is really backwards, right? You really should simplify, oh gosh, this pen, this stylus has a button on it that does that. You want to simplify first, right? And again, that just means factor and cancel. Right. Then we'll multiply, right? So for the first numerator, 3x squared plus 12x, the GCF is 3x. And when you factor that out, you get x plus 4. Right. Nothing else to do there. For the denominator, 6x cubed plus 24x, the GCF is 6x squared, leaving you with, again, x plus 4. And we can see we can cancel the x plus 4's right away. I'll save that for later. Right? Now we have to factor the second numerator, the 4x squared minus 8x minus 12. And I'm going to do this in 2 steps here. Right? First is the GCF. The GCF is 4. So you factor out the 4. So it's 4 times x squared minus 2x minus 3. So then you factor the trinomial, right? The only possible way to do this is, well, there's 2 ways, I guess. There's minus 1 plus 3, but that adds to positive 2. We want a negative 2. So that means it's going to be positive 1 and negative 3. So that's the second numerator. 4 times x plus 1 times x minus 3. The denominator should be easy. A squared minus b squared, right? It's just a minus b times a plus b. Okay, so I think we're factored completely, more or less. We'll still do the 6 and the 4, right? So 4, of course, is 2 times 2, and then times 3, times x plus 4, times x plus 1, times x minus 3. Okay, so that's the whole numerator now. And then in the denominator, we have 6, which is 2 times 3. And then we have x squared. I'll write it as x times x, right? Times x plus 4, times x minus 3, times x plus 3. Now we're factored completely, right? Nothing else to factor. So now we just cancel. 2 divided by 2 is 1. 3 divided by 3 is 1. X divided by x is 1. X plus 4 divided by x plus 4 is also 1. And x minus 3 divided by x minus 3 is also 1. Okay, so all that's left in the numerator is, let's see, we have a 2 times x plus 1. And all that's left in the denominator is this x times x plus 3. That's an x. All right. That's it. Nothing else to cancel. So we're done. Right? So that's number 3, part B. Okay, part C. I'm going to multiply and simplify 2y squared plus 3y plus 1 over y squared minus y minus 2 times y plus 2 over y squared plus y minus 2. So again, let's factor everything and then cancel. For the first numerator, technically it's the AC method, but there's really no choice here because 2 times y is 2y squared, and 1 is, well, 1 times 1. So it has to factor this way, 2y plus 1 times y plus 1. If you use the AC method, you would get the same thing. For the denominator, it's got to be y and y times y is y squared. And now it's just a matter of, is it positive 1 times negative 2 or negative 1 times positive 2? Well, let's do the cross terms, right? It's negative 2 negative 2 plus 1 is negative 1. So I think I got it right. Y plus 1 times y minus 2. And then for the second numerator, we just have the y plus 2, right? That's prime. There's no way to factor that. But the denominator is going to be, well, now it's just the opposite, right? Y times y is y squared, and we still have the negative 2, but now we want them to add to a positive 1, right? So that means we switch the signs here. It's going to be negative 1 times positive 2. Okay, so that's everything factored completely. In fact, we can just multiply straight across here. And now just cancel. So what are we canceling? Well, y plus 1 over y plus 1 is 1, so they cancel. What else? How about y plus 2 over y plus 2? They cancel. I don't see anything else that cancels here, right? So I think we're basically done. The numerator is just 2y plus 1, and the denominator is y minus 2 times y minus 1. And it really is best to leave it factored here. You could multiply out the denominator as y squared minus 3y plus 2. I'm not against doing that, but it's not necessary. It's probably best to leave it in factored form here. Okay. Again, I would accept either, but if you look in the back, right, of the practice test, you'll see the answer written this way, I believe. So I hope that helps. Okay, so I'm skipping 3D. It's done much the same way, and I don't think it's really any more difficult than B or C. So let's go on to number 4a. Now we're dividing and simplifying. Okay, so we have 9u squared minus 16 over 12u plus 16 divided by 6u squared plus 4u minus 16 over 8u plus 24. I just want to make sure I got it right here. Yep. Okay, so yeah, so remember the first thing you do when you divide is keep, change, flip. You keep the first fraction as it is. You change division to multiply. I shouldn't use an x for multiply. Usually I just use a dot for multiplying here, right? And then you flip the second fraction. So you put the 8u plus 24 in the numerator, and then the 6u squared plus 4u minus 16 in the denominator. Right. So once you do that, it's the same as number 3 now, right? Now you just simplify, which is, again, factor and cancel. So the first numerator here is, again, a squared minus b squared. So that factors as a minus b times a plus b. In this case, 3u minus 4 over 3u plus 4. For the denominator, 12u plus 16, well, the GCF is 4, so we factor out the 4, leaving you with 3u plus 4. Again, you can already see that the 3u plus 4 will cancel, but that's getting ahead of ourselves. Let's factor the second fraction as well. So the numerator, 8u plus 24, you factor out the 8, and you get u plus 3. Okay, it's the second denominator that's probably the trickiest, right? Because it looks like AC method here. So I'm going to do that way up here now. So 6u squared plus 4u minus 16. So a is 6, b is 4, c is negative 16. So a times c is 6 times, hang on, I'm forgetting the most important thing here. The GCF is 2. So we should factor out the 2 first. Okay, so 2 times 3u squared plus 2u minus 8. And if that looks familiar, it's almost the same as number 3, part D here, except with u's instead of x's. Okay, so well, yeah, it's a u, not an x. Sorry about that. So 3u and u, and then the middle terms here have to add to positive 2. So I think it's going to be a 4 here and a 2 here, right? 6 minus 4 is 2. Okay, so that's the denominator here. I'll just copy it down. We have the 2, 3u minus 4, and u plus 2. Right, now we can combine everything into one big fraction. I'll put the 8 in front. Remember, 8 is just 2 times 2 times 2. And then the 3u minus 4, 3u plus 4, and u plus 3. For the denominator, we have a 4, which is 2 times 2, and then another 2, so I'll bring that in front. And then we have 3u plus 4, right? 3u minus 4, and u plus 2. Okay, so I think we're factored completely. Now we can just cancel. What are we canceling? Well, the 2's, these 2's, and these 2's. So if you didn't factor it out completely, what you would get here, of course, is just 8 divided by 8, which is 1. So the 8's cancel. So either way, all the numbers cancel here, right? The 3u minus 4 cancels with the 3u minus 4 in the denominator. The 3u plus 4 cancels with the 3u plus 4. And these are different, right? U plus 3 is not the same as u plus 2, so they don't cancel. But everything else did. So all we're left with is u plus 3 over u plus 2. Right? That has to be the answer. Okay, be careful because it's very tempting to cancel the u's, but those aren't factors, those are terms. If you cancel those, if you end up with 3 over 2, that's wrong. Okay, so you cannot cancel the 2's because you're not multiplying, you're adding, right? Think of it this way. If it was 3 times u over 2 times u, yes, then you can cancel the u's, right? This would just be 3 over 2. But because it's u plus 3, or 3 plus u over 2 plus u, because of the pluses, right, they're not factors. They don't cancel. Okay, so big difference between multiplying and adding, right? When you're multiplying, you can cancel. When you're adding, you cannot. Okay, so that's number 4, part A. Let's do part B as well. Okay, so again, we want to divide and multiply 6x squared plus 6x over 3x plus 6x squared plus 3x cubed divided by x squared minus 1 over 1 minus x cubed. Right, so first step is always keep, change, flip. I'm not even going to try to factor anything yet. We can do that later. One thing I will do, though, is switch the order here. This seems backwards to me, right? You always put the biggest power in front. So I will switch this. 3x cubed, then 6x squared, then 3x. You don't have to, but it will make it easier later. All right, change the division to multiply, and then flip the second fraction, so it's 1 minus x cubed over x squared minus 1. And actually, the 1 minus x cubed also looks backwards, but because we're subtracting, right, we can write this as negative 1 times x cubed minus 1. So I'll just factor out the negative 1. Again, you don't have to. It's just a personal preference of mine. All right, so that's keep, change, flip. Now we factor and cancel. Okay, so for the first numerator, well, the GCF is 6x. I hope that's obvious. So that multiplies x plus 1. In the denominator here, well, we can factor out a 3x, leaving us with x squared plus 2x plus 1. And then that factors as x plus 1 times x plus 1. So it's a two-step process here. Factor out the GCF first, and then factor the trinomial x squared plus 2x plus 1 as x plus 1 squared. Or, in this case, it's okay to write it as x plus 1 times x plus 1. You can see that because we're going to cancel one of the factors there. Let's do that later. All right, so for the first numerator here, we have the negative 1. Right? We're not subtracting 1, we're multiplying by negative 1. So let's put parentheses around the negative 1. And then the x cubed minus 1, I'm going to do that way up here. You should recognize this as x cubed minus 1 cubed, right? Or a cubed minus b cubed. And you should remember that factors as a minus b times a squared plus ab plus b squared. Way back in chapter 6, we did that, right? So here a is x and b is 1. So that means we're going to factor this as x minus 1 times x squared plus x times 1, which is x, plus 1 squared is 1. So yeah, that was a little tricky because of the cubes, but it is negative 1 times x minus 1 times x squared plus x plus 1. Okay, and the denominator is easy. A squared minus b squared, a minus b times a plus b. In this case, x minus 1 times x plus 1. Okay, so that's the factoring. I think we're done factoring. Now let's just organize everything here. The 6, of course, is 2 times 3, right, times x. Times a negative 1. So maybe I should put the negative 1 in front here. And then the 2 times 3 times x. And then the other factors are x plus 1, x minus 1, and finally the only trinomial that we cannot factor, x squared plus x plus 1. Yeah. Again, you can try to factor this, but you won't be able to. It's prime. In the denominator, we have a 3 and an x, and then we have x plus 1. We have another x plus 1. We have another x plus 1 way over here, right? And then we have an x minus 1 here. All right, so what cancels? The 3's, 3 divided by 3 is 1. X divided by x is 1. X plus 1 divided by x plus 1 is also 1. And x minus 1 divided by x minus 1 way over here. So I think that's it. So negative 1 times 2 is just negative 2. And then the trinomial, x squared plus x plus 1. Nothing we can do with that. And in the denominator, we have x plus 1 times x plus 1. At this point, it's probably best to write it as x plus 1 squared. Okay, so that's 4b. Again, not an easy one, in particular because you had to remember the difference of cubes. Again, it doesn't come up very often, but when it does, you should know it. You should know it by now. Okay, let's move on to number 5. Okay, so number 5, now we're going to be adding and subtracting fractions, right? And of course simplifying as well. So I'm going to skip A because I think it's fairly standard. It's pretty straightforward. And in fact, B is very similar. And I think it's a little bit harder because, well, there's 3 fractions instead of just 2. But otherwise, it's done much the same way. Okay, so how do we subtract the first 2 fractions and then add the third one? So remember the steps here. The first thing you have to do is find the least common denominator. And how do we do that? Well, we write down all the denominators and we factor them completely. So let's factor the first denominator. Again, there's not much to factor, just the 10. 10 is 2 times 5. So 2 times 5 times a squared times b times c cubed. The second denominator here, 15ab to the 4th c. So 15, we factor that as 3 times 5. And then a times b to the 4th times c. And then the third denominator here, 3ab, 3 is prime, so I'll leave the 3 times a times b. So the LCD, least common denominator, is just the product of each factor using the biggest exponent, right? And for the numbers, all the exponents are just 1s. That makes it easy. So we just multiply each number, right? We have a 2, a 3, and a 5. What about the a's? We have a choice between a 1 and a 2. We pick the bigger one, right? The 2. For the b's, we have a choice between a 1 and a 4. We'll pick the bigger one, the 4. And for the c's, we have a choice between a 1 and a 3. Again, 3 is biggest, so we'll pick the 3. So the LCD, 2 times 3 is 6, and 6 times 5 is 30. So the LCD should be 30 a squared, b to the 4, c to the 3. Okay. Well, that's just the first step, right? Remember, the second step now is to rewrite each fraction so that the denominator is this. It's the LCD here, right? So let's see, how do we do that? I'll write the first fraction the same way, right? 3x times, let's do 2 times 5 times a squared times b times c cubed. Okay, so what's missing here, right? We have 2 times 5, but we're missing a 3, right? 10 times 3 is 30. So we need to multiply by 3. We have the a squared, but we need b to the 4th. We only have b to the 1, so we're missing 3 factors of b, right? We're missing b to the 3. And we have the c to the 3, right? So we don't need any more c's. So the missing factor here was just 3b cubed, right? Okay. Minus, and I hope I don't run out of room here. I'll try to squeeze this in. 15ab to the 4th c in the denominator, right? So what are we missing here? well, we need to get, so I didn't write it as 3 times 5, right? But it's 15 and we need 30. So 15 times 2 is 30. Okay. We only have a, we need a squared, so we need another a. Right, top and bottom. We have b to the 4th, so we don't need any more b's. We have a c, but we need c to the 3rd, right? So we need 2 more c's, c squared. Right. And then finally, we have x squared over 3ab. So now we need to multiply by, so 3 times what is 30? Right, 3 times 10 is 30. So we need a 10. We need a squared. We only have a, so we need another a to get a squared. We only have one b, so we need b to the 3 again to get to b to the 4. And we need all the c's. We don't have any c's here, right? So we need c cubed as well. Just squeeze it in there, right? So that's my step 2. So now let's just multiply everything across here. We have 3 times 3 is 9 times x times b cubed. And then the denominator should be the least common denominator, right? So 2 times 5 is 10. 10 times 3 is 30. So we have 30 a squared b to the 4th times c to the 3. Minus, right, because that's a minus here. 4 times 2 is 8. And then times a times c squared. The denominator will be, well, it better be the same thing. 30a squared b to the 4th c cubed. Plus, right, because that's a plus. Let's put the 10 in front. We have x squared a b cubed c, oops, sorry, c cubed. And then the denominator will again be 30 a squared b to the 4th, c to the 3. Okay, so now we can go on to step 3. Right? Step 3, notice that all 3 denominators here are exactly the same. In fact, they are the least common denominator. That's the whole point for doing all this, right? We couldn't add or subtract anything until we get the denominator to be the same. Now it's the same for all 3. Okay, now we just add and subtract the numerators. So 9, I'll go in alphabetical order here. I'll put the b first. B cubed then x minus 8 ac squared plus 10, same thing. I'll put the a first, and then b cubed, c cubed, and then x squared. Again, the order doesn't matter when you're multiplying. I'll just put it in alphabetical order. And there's really nothing else to do here, right? Step 4 would be to simplify this. But simplify means factor and cancel. So I certainly can't factor anything out of the denominator. It's already factored. I mean, we could write the 30 again as 2 times 3 times 5. But you can see that nothing cancels in the numerator, right? What can we factor out of the numerator here? And the answer is nothing. The GCF is 1. And so it is a trinomial, but trust me, it's just not going to factor. I mean, and even if it does, we're not going to worry about that, right? I don't think it factors. I think it's prime. Pretty sure. So that's the answer, right? So there's nothing here there's nothing to simplify in this problem here, right? Okay, so that's the idea, right? Step 1, find the LCD. Step 2, rewrite all the fractions, right, by multiplying by any missing factors. These are the missing factors here, and that should give you the same denominator, right, for all 3 fractions. Then you just add and subtract the numerators. And at that stage, if you can factor and cancel, you should. In this case, there's nothing to factor, there's nothing to cancel. So, right, so this is our final answer here, I think. Just circle it again. All right, so that's 5b. Let's go on to 5c. Okay, 5c, add and simplify 5a over 2a plus 1 plus 3 over 2a minus 1. Okay, so it's pretty much done the same way. Step 1, what's the least common denominator? Well, we only have two denominators, 2a plus 1, and 2a minus 1 is not the same denominator, right? They're not exactly the same. They would both have to be plus, or both minus, for them to be the same. Right? And those are prime. There's nothing to factor, right? They're not the difference of squares. They're not, the GCF is 1. So we're just going to multiply each factor, right? The LCD is just 2a plus 1 times 2a minus 1. Okay? And in fact, you can always find a common denominator just by multiplying all the denominators. In many cases, when you do that, you won't get the least common denominator, so you're making it harder than it has to be. In this case, though, it turns out that just by multiplying the two denominators, you end up with the least common denominator. Okay, so the least common denominator is just the product of the two denominators. Okay, so for your step 2 here, I'm just going to rewrite the problem. 5a over 2a plus 1, leave some space, plus 3 over 2a minus 1. Right, so what's the missing factor for the first fraction? Well, we have the 2a plus 1. We're missing 2a minus 1. So I'm going to have to multiply numerator and denominator by 2a minus 1. Right. And if I do that, I should put parentheses around the 2a plus 1. Same thing here. Right. Now for the second fraction, it's the complete opposite. We have the 2a minus 1. Right? What we're missing is the 2a plus 1. So I'll multiply top and bottom by 2a plus 1. Okay. All right, so what do we have? We have 5a, sorry, that's a 5, times 2a minus 1 over 2a plus 1 times 2a minus 1 plus, and then for the second fraction we have 3 times 2a plus 1 over 2a minus 1 times 2a plus 1, but just to show you that the denominators are exactly the same, I can always switch the order, right? I can always switch these because you're just multiplying, right? And so we end up with 2a plus 1 times 2a minus 1. Okay, so at this stage you should notice that the two denominators are exactly the same. So all we do now is add the numerators. Okay, so keep the denominator. You could multiply it out, but as a general rule, I wouldn't. I would leave it factored, leave it as it is. And then the numerators, we just add those. 5a times 2a minus 1 plus 3 times 2a plus 1. Okay. Right. Now here's where it gets tricky, because a lot of people look at this and say, oh, I can cancel the 2a plus 1s, I can cancel the 2a minus 1s. That would be very bad. That would be wrong. You cannot do that. Right? You're not multiplying everything in the numerator. This is still a plus. Right? The numerator is not factored yet. Okay? So because of the plus sign, and let me make it even clearer that this is a positive sign here, we still have to multiply out the numerator, and then maybe we can factor it, right? And I think I have just enough space here. So if I multiply out the numerator, I get 5a times 2a. So 10a squared minus 5a, and then plus 3 times 2a is 6a, plus 3 times 1 is 3. All over, same denominator. Do not multiply out the denominator. Okay. So the only thing left to do in the numerator is negative 5a plus 6a is positive 1a. So 10a squared plus a plus 3. All over 2a plus 1 times 2a minus 1. Okay. And now we must be done, right? Possibly, right? Again, can we factor this numerator? Right? It is a trinomial. The GCF is 1, but we can use the AC method, right? So A is 10 and C is 3. A times C is, what, 30? So can we find two numbers that multiply to 30 and add to 1? Okay. So yeah, it's obviously not 1 and 30, because that adds to 31. It's not 2 times 15, because that adds to 17. It's not 3 times 10, because that adds to 13. And it's not 5 times 6, because 5 plus 6 is 11, right? You're not subtracting them. It's not 6 minus 5. It's 6 plus 5, which would be 11. So I think that takes care of all the possibilities, right? The numerator here is prime. It is not factorable. Okay? I mean, you have to try, because if it is factorable and you do leave it like this, you'll get points off for not simplifying completely. But as it happens, the numerator is prime, so that means this is as far as we can go. This is the final answer. Okay? And, which is good because I just ran out of space, but that's as far as we can go for number 5. Sorry, for 5C. We'll do more in 5, just not for 5C. All right, so 5D, subtract and simplify. 2x over x squared minus 7x minus 8, and then minus x plus 2 over x squared plus 5x plus 4. Okay, so step 1, find the LCD. As always, right? Unless the denominators are already equal, which does happen occasionally, but not in this case. These are not the same. So that means we have to factor both denominators. And luckily, these factor pretty easily. What two numbers multiply to 8, or negative 8, I should say, and add to negative 7? So it's just negative 8 and 1. For the second denominator, x squared plus 5x plus 4. Not much of a choice here, right? 4 is either 2 times 2, but 2 plus 2 is 4, or it's 1 times 4, right? And 1 plus 4 is 5. Okay, so first thing is let's just write this with the denominators already factored. X minus 8 times x plus 1 for the first one, and then minus x plus 2 divided by x plus 1 times x plus 4. Okay. We never finished step 1, though. What's the LCD? Well, it's just the product of all the factors. We have an x plus 1, we have an x plus 4, and we have an x minus 8. So that's going to be our LCD. Right? Don't make the mistake of saying it's x plus 1 times x plus 1, and so that gives you x plus 1 squared. It's not as harmful to do that, except that it's just not necessary. It's no longer the least common denominator. It's a bigger common denominator, right? I mean, why stop there? Why not make it x plus 4 cubed, or x minus 8 to the 5? You can always make the exponents bigger. You can make them as big as you want, but you cannot make them smaller, right? So you do need the factor of x plus 1 and the x plus 4 and the x minus 8. You need all three of them, right? Because that's the biggest exponent is just 1. Right? But you don't need the exponents to be any bigger. You don't need the 2 there. Okay? All right, so what are we missing in the first term? Right? So that's our step 2 now, multiplied by any missing factors. So we have the x minus 8 and we have the x plus 1. Right? So we're missing x plus 4. So multiply top and bottom by x plus 4. Right. For the second fraction, we have the x plus 1, we have the x plus 4, we're missing x minus 8. Right? So multiply by x minus 8 in the numerator and the denominator. All right, so what do we have? We have 2x times x plus 4. We'll multiply that out later, right? But we will do that. And the denominator, let me just put this in the order of the LCD. I'll do x plus 1 first, then x plus 4, and then x minus 8. Again, order doesn't matter when you're multiplying, right? Minus, and then we have x minus 2 times x minus 8 all over, okay, the denominator is exactly the same. X plus 1, x plus 4, x minus 8. Okay. All right. So the whole point for doing all that is to make sure the denominators match. The denominators have to be exactly the same. Okay. So yeah, be very careful here because it's very tempting to cancel the x plus 4s and the x minus 8s. But why would you do that? Because then you're just going backwards. You're going back to the previous step. And in fact, you're really just going back to the beginning. And remember, we can't subtract these unless the denominators are equal, right? So yeah, if you cancel these common factors now, you're going backwards, okay? So even though these are not in lowest terms, they're not simplified, we need to write it this way, at least temporarily, so that we can now subtract the two fractions. And that's the third step, right? The third step is to subtract the two fractions to get one big fraction here. Keep the denominator, it's already the same, x plus 1, x plus 4, and x minus 8. Right? Now we just subtract the numerators. 2x times x plus 4 minus x minus 2 times x minus 8. And that numerator, we're going to have to multiply all that out here, right? So that's the next thing we do. 2x times x will be 2x squared. And then 2x times 4 will be 8x. Minus all of this, right? This is just FOIL, right? X times x, x squared. X times negative 8 is negative 8x minus 2x. And then negative 2 times negative 8 is positive 16. Right, all over the same denominator. Right. Oh, one thing we can do in our heads here, negative 8x minus 2x, right, is negative 10x. So we'll just fill that in. Oop, careful. This is minus 10x. Okay. All right. And now don't forget to distribute the negative here. That's one thing a lot of students have trouble with. So be very careful. You're subtracting the whole thing, right? So you're subtracting the x squared. You're subtracting a negative 10x, and you're subtracting the 16. Right? So that really means you're adding 10x. It's a negative times a negative, which is positive. Minus a positive is a negative, right? Right, so this is all really just simplifying the numerator here, right? So like terms, we have 2x squared minus 1x squared is 1x squared. We have 8x plus 10x is 18x. And then we just have the negative 16 at the end, right? All over x plus 1 times x plus 4 times x minus 8. Oh boy. So, okay, I'm looking at the answer now, and the answer is something different. Slightly different. I get x squared plus 14x minus 16 over x plus 1 x plus 4, x minus 8. So the denominator is correct. The numerator, so I'll tell you right now, the numerator, you can try to factor it. Either way, these are not factorable. But the big issue here is that somehow I got 18, and I think the answer should be 14. I just figured it out. All right, so way up here, right, the original problem was x plus 2 for the second fraction. That's the x plus 2. And somehow in this step here, right here, I changed that to an x minus 2 for no reason at all. That should have been a plus 2 here. right? So that should be a plus 2. So when you multiply this out, you get negative 8x plus 2x, which is negative 6x. And I got a negative 10x, which is wrong. So let's fix that. Erase the minus 10x and make it a negative 6x. And when you subtract a negative 6x, you get a positive 6x. So this positive 10x should be a positive 6x. And now 8x plus 6x is 14x. Okay. So, yep, this was wrong slightly, but it is wrong. This should have been a 14x, right? 8x plus 6x, not 8x plus 10x. So, yep, just changing that one little sign here, the plus 2 to a minus 2, that messed me up completely here. I'm sure I'm not the only one to make those kind of mistakes. We all make those mistakes. I'm glad I caught it, though. I'm glad I caught it last minute. And anyway, so that should do it. This should be your answer. Of course, you should also check that the numerator is not factorable. What two numbers multiply to negative 16 and add to 14? There just aren't any, right? There's negative 1 times 16, but that adds to 15, which is close, but it's not 14. Right? And then negative 2 times 8 is also negative 16, but negative 2 plus 8 is 6. I made that mistake earlier, right? But 6 is also not 14, so there's no match there. And the only other possibility is, right, negative 4 times 4, but negative 4 plus 4 adds up to 0, which of course is not 14. So there is no match here. So the numerator really is prime. It's not factorable. Let me erase the little arrow here. And so that's our answer for 5D. Okay. Yep, not an easy one. And, make little mistakes like switch a minus to a plus, or in this case, a plus to a minus. That will probably mess up the answer, as it did in this case. All right, let's move on. All right, 5E, subtract and simplify 2x squared over x squared minus 1 minus x over x minus 1. Again, seems simple enough, but let's go through the steps. We have to find the LCD. So the first denominator is x squared minus 1, and that factors as x minus 1 times x plus 1. The second denominator is x minus 1, which is prime. It doesn't factor at all. It's still just x minus 1. So the LCD is then the product of all the factors. We have an x minus 1, and we have an x plus 1. So that's our LCD. Right? And so for the first fraction, let me just factor the denominator as x minus 1 times x plus 1. And that is the LCD. Right? There's nothing missing, so we don't have to multiply anything here. Now for the second fraction, we have x over x minus 1. But the least common denominator is x minus 1 times x plus 1. We're missing the x plus 1. So for that, we need to multiply top and bottom by the missing factor, x plus 1. Okay. So the first fraction, we can leave that alone. It's still 2x squared over x minus 1, x plus 1. The second fraction is x times x plus 1 over x minus 1 times x plus 1. And I warned you about this last time. Don't cancel the x plus 1s, because then you're back to square one again. You're back to the original problem, right? And we cannot subtract these because they don't have the same denominator, right? This 2 here ruins that. Otherwise, they would be the same, and then it would be too easy. Okay, but now notice the two denominators here are exactly the same. X minus 1 times x plus 1, right? It is the least common denominator up here. So, right, so our third step, this was step 2, by the way. Our third step is just to subtract the two numerators. So we have 2x squared minus x times x plus 1. And then the denominator, we'll leave that alone, x minus 1, x plus 1. Okay, again, still nothing cancels, not yet anyways. So we have to multiply the x times x and x times 1, or I should say it's a minus x, right? So negative x times x is negative x squared, and negative x times 1 is just negative x. So just expand that out. And, well, 2x squared minus 1x squared is 1x squared. I don't need the 1, right? It's just x squared. Oops. Minus x. All over x minus 1 times x plus 1. All right. Is that it? Well, there's the step 4 that we didn't get to yet. Simplify, right? Simplify means factor and cancel. The denominator is already factored, right? At least it should be, unless you made the mistake of multiplying it out again and writing it as x squared minus 1. That would be bad, right? Instead, we want to take the numerator and factor it. And I hope that's easy enough, right? Because this is just the GCF is x, so just factor out an x, and you get x minus 1. So the numerator is x times x minus 1. The denominator is x minus 1 times x plus 1. Now that we're completely factored, we just cancel the common factors, in this case, x minus 1. Well, what are we left with? In the numerator, it's just an x. In the denominator, it's just x plus 1. And there's our answer, right? Yes, do not cancel the x's. That would be bad. They're not factors, right? This is a plus sign. So that's it, right? So all of this is really just, oops, x over x plus 1. Okay. All right, good. And I'll do f as well. Add and simplify 6 over y plus 1 over y plus 2 plus 2 over y squared plus 2y. Okay, so what makes this maybe a little bit trickier is the fact that there's 3 fractions. We've already seen one of these, right? Part B, number 5b, had 3 fractions, although one of them you had to subtract, one you had to add. Here you're adding all 3. Okay, but again, the denominators are not identical. They're not the same. We cannot add or subtract anything just yet. So as always, we have to find the LCD. Let's factor all the denominators. The first denominator is y. Y is y. There's nothing to factor. It's prime. The second denominator is y plus 2. That's also prime. The third denominator is y squared plus 2y. Well, you can factor out the GCF, which is y. So the third denominator is y times y plus 2. So our LCD has to include the y and the y plus 2. Those are the only 2 factors, right? I see a y, I see a y plus 2, right? This denominator already has the y and y plus 2. All right, so our second step, if you remember, is to get the same denominator. We have 6 over y plus 1 over y plus 2 plus 2 over, and then we'll rewrite this in factored form, y times y plus 2. Okay, so let's start with the first denominator, 6 over y. What are we missing? We're missing the y plus 2. So we need to multiply top and bottom times y plus 2. Don't forget the parentheses. Very important. For the second fraction, it's the opposite. We have the y plus 2. We're missing the y. So here, we just multiply by y over y. And don't forget the parentheses here. And the third denominator is y times y plus 2, but that is the LCD. We're not missing anything. So there's nothing to multiply here. I mean, you could do 1 over 1, but it doesn't matter, right? It's the same thing. So the third denominator here, this is already the LCD. So we don't have to fix it. We don't have to multiply by anything there, right? All right, so that leaves us with 6 times y plus 2. And I could multiply this out already. You know, I tend to do that later. Right. So let's do that later. Plus, and then 1 times y is y over y times y plus 2. Right? Yep, you can put the y in front. Order doesn't matter when you're multiplying. And then plus 2 over y times y plus 2. Okay. So yes, again, don't cancel anything, right? If you cancel these, you're just back to the original problem, and you're not going to make any progress that way. Instead, the whole point of doing all that mess is to get the same denominator for all three fractions. Once you have the same denominator, now you just add the numerators. And then keep the same denominator. Right. All right, now we should multiply this out. 6 times y, well, is 6y, plus 6 times 2 is 12, plus y plus 2. Okay. With me so far? So, like terms, we have 6y plus 1y. That's going to be 7y. And then the 12 plus 2 is going to be 14. And I did put the y in parentheses. It's not necessary. Right? I mean, if you want to, you can, but it's only a single term monomial. All right, so we're almost done, right? That's step 3. Step 4 is just to factor and cancel. Right? Yeah, so step 3 was to, you know, add the numerators here. Right? Yeah, the only thing to factor in the numerator is just the GCF, which is 7. So if I factor out the 7, I get 7 times y plus 2, divided by y times y plus 2. Well, look at that. We can cancel a common factor of y plus 2. It is a common factor. It cancels. So our final answer is just 7 over the y. Right? Again, if you leave it like this, you didn't simplify. Right? This is not simplified. So take the last step here, factor and cancel. Right? So that should be our answer, 7 over y. So all of this, when you add these fractions here, you end up with 7 over y. Okay? All right, so that's 5f. Okay, I'm skipping G, 5G. It's just pretty similar to this one here, or even 5e. They're all subtracting, right? So subtract and simplify. This is 5h. X over x squared plus 11x plus 30 minus 5 over x squared plus 9x plus 20. So again, the denominators are not the same, but we can factor these pretty easily, right? What two numbers multiply to 30 and add to 11? So it's not 1 and 30. It's not 2 and 15. It's not 3 and 10. 3 plus 10 is 13, right? That doesn't work. 5 times 6 is 30. 5 plus 6 is 11. So 5 and 6. Right? And then for the second denominator, we have, oh, forgot to leave some space here. What two numbers multiply to 20 but add to 9? So it's not 1 and 20. It's not 2 and 10. It's 4 and 5, right? 4 plus 5 is 9. Okay, so what is the LCD here? We have two denominators. One is x plus 5, this is part A, times x plus 6. The other denominator is x plus 4 times x plus 5. So putting them all together, the LCD is x plus 4, x plus 5, x plus 6. In that order. I'm kidding. It doesn't matter what order it is. right? So yeah, you can have x plus 6, x plus 4, x plus 5, any combination. But you have to include all three factors, right? If you said x plus 5, that's the GCF. That's the GCF. We're not looking for the GCF here. We're looking for the LCD. So we have to include all the factors, right? All right, so step 2, what's missing from the first fraction? We have x plus 5 and x plus 6. Well, we're missing the x plus 4. So multiply top and bottom by x plus 4. For the second fraction, we have x plus 4, x plus 5. We're missing x plus 6. So multiply top and bottom by x plus 6. Right? So that's the numerator. Let me put the x plus 4 first. And then minus 5 times x plus 6 all over same denominator, x plus 4, x plus 5, x plus 6. Right. And again, I'm not going to stop you. If you want to multiply this out right away, you can. So I could have skipped that step and just went right to this. And 5x plus 30. Okay. Again, I was going to do that after the next step, but you could do it now as well. All right, so step 3, notice that the two denominators are identical. X plus 4, x plus 5, x plus 6, same denominator. Now I just subtract the numerators, right? So leave the denominator alone. Do not multiply that out. That would be a lot of work, and it's counterproductive to do that. However, the numerator here is x squared plus 4x minus 5x plus 30. And I hope you saw my mistake here. I just made a mistake on purpose, but this is a common mistake, so be careful. This plus is wrong, right? It should be a minus. Okay? And this is the problem with multiplying this out first here. It's a lot easier to make that mistake. Right? You have to subtract the entire numerator. So either leave the parentheses around the 5x plus 30, or distribute the negative, right? You get negative 5x, and then a negative times a positive makes it a negative 30 here, right? So get rid of the parentheses, but change the plus here to a minus. Oops. Hang on. Yep. Yep. If you make it a plus, well, you're just going to get it wrong. So be careful, right? In fact, you can always put parentheses around anything here just to make sure you distribute the negative sign, right? All right, so let's see. 4x minus 5x is just negative 1x. And that's the numerator. Just copying down the denominator. Right. And now simplify if possible. So can we factor the numerator? Again, the denominator is already factored, unless you made the mistake of, expanding it out, foiling it out. I already told you, don't do that. You're making it harder. But the numerator we have to be able to factor. So what two numbers multiply to negative 30 and add to negative 1? Spoiler alert, it's going to be negative 6 and positive 5. Right? Negative 6 plus 5 is negative 1. Negative 6 times 5 is negative 30. Right? So you would see, if you did make this a plus 30 by mistake, it would be prime. You wouldn't be able to factor, I don't think. Yeah. So then you would leave your answer like this, which of course would be wrong, because it's not a plus, it is a minus 30. Right. And now there's only one thing left to do. Yep, cancel the x plus 5. Because that's our common factor. So the numerator is just x minus 6. Parentheses are optional there. We don't need them. And then the denominator is x plus 4 times x plus 6. And here you do need the parentheses. And that's it. Yep, you don't cancel the 6's. They're not factors, right? You could multiply out the denominator at this stage, but again, there's no point in doing that. I would accept it. It is correct, but it's better to leave it factored like this, right? Okay. And I just noticed in the answer key, I wrote it the other way. X minus 6 over x plus 6 times x plus 4. Obviously, that's correct as well, because you can always switch the order of the factors. Okay. So that's number 5. Let's move on to number 6. Okay, number 6, simplify the complex fractions. And you remember my complaint. I don't like the word complex fractions. It has nothing to do with complex numbers. I prefer the term compound fractions. But whether you call them complex fractions or compound fractions, it's the same idea. You have fractions within fractions, right? So here the numerator is a fraction and the denominator is a fraction, and we want to simplify. Okay. So there's two ways of doing this, right? For lack of a better name, they're just called method 1 and method 2. So in this case, I think if I remember method 2, I think that works easier here. And the way this works is, right, we already have a fraction divided by a fraction. Okay, so we can simply turn this into a division problem. 4a over a minus 4 divided by 8 over a squared minus 16. Okay, and we did this before, right? This was way back in, I believe, number 4, where we divided fractions. So keep, change, flip. Keep the first fraction, change to multiply, and then flip the second fraction. And then factor and cancel, right? So there's not much to factor here. I'll leave the 4a, the a minus 4. The only thing that you're factoring here is the second numerator. A squared minus 16 is a minus 4 times a plus 4. Right? That's your a squared minus b squared. And 8 is actually just 4 times 2. Right? And the reason why I'm writing it that way is because I want to cancel the 4's. Right? And maybe before I do that, let's write this all as one big fraction now. Right? So we have 4 times a minus 4 times a plus 4. That's the numerator. The denominator is 4 times 2 times a minus 4. I'll just put the 4 and the 2 in front. Okay, so now we can cancel the 4's. And we can also cancel a minus 4. And I think that's it. Right? That's all that cancels. So the numerator is a times a plus 4. The denominator is just 2. And we're done. Right? I mean, if you want to multiply out the numerator, that's okay, but it's not necessary. I would accept either. Okay, so that's 6a. Let's go on to 6b. Okay, so here we want to simplify y plus 2 over 3y over y minus 4 over y. Now, this one cannot quite be done the same way as the previous one. You could try, but a lot of people really mess this up here, right? You can think of this as y plus 2 over 3y divided by y minus 4 over y. But the problem is, this is not a fraction, right? It's two fractions. It's y over 1 minus 4 over y. Okay, so if you're going to do it this way, you have to subtract these two fractions, right? Get a common denominator, and so on, right? So this is not the way I would prefer to do it, but if you're going to do it this way, right? So let's see. Our common denominator here is just y's. So we're going to get y squared over y minus 4 over y. And then when you subtract the numerators, you're going to get y squared minus 4 all over y. Now it's a single fraction, right? Now it's one fraction. Right, so now we can keep change flip. Multiply by the reciprocal, flip the second fraction, right? Now you just factor. And in fact, the only thing that you can factor here is the second denominator. Y squared minus 4 is y minus 2 times y plus 2. So putting everything together, we have a y times y plus 2 on the top. We have a 3 times y minus 2 times y plus 2 in the denominator. So what cancels? The y's and the y plus 2's. So what are we left with? Oh, sorry, I didn't mean to switch colors on you. Still yellow. So the denominator is clearly just 3 times y minus 2. What's the numerator? Yeah, we canceled everything, right? We canceled the y and the y plus 2. But what's left over is this invisible 1 in front, right? You're multiplying 1 times y plus 2. You cancel the y and the y plus 2, leaving you with the 1. Right? It's not 0, it's 1. Okay. Again, you can also write this as 1 over 3y minus 6. I would accept that, but there's no reason to multiply it out. I would leave it factored. Okay, so that's one way to do part B. Here's the other way. Okay, so here's the original problem. Again, I'm doing 6b again. Is to notice that the denominator here, right, is two fractions, right? Y over 1 minus 4 over y. So the LCD out of all these fractions here is 3y, right? Or 1 times 3y. So the LCD is 3y. So I'm going to multiply this fraction by 3y over 1, and the difference of these fractions also by 3y. Okay. So all I did was multiply by 1. 3y over 3y is 1. Right? But for the numerator here, I have y plus 2 times 3y over 3y times 1. For the denominator, here I have to multiply that out, right? So I have y times 3y over 1 times 1 minus 4 times 3y over y times 1. Right. And I grant you that it's kind of a mess at this point, but we can clean this up pretty easily. After all, 3y over 3y is 1, so the 3y's cancel, leaving you with just the y plus 2, right? Over 1, but we don't need the 1, right? Now for this part of the denominator, 3 times y is 3y squared. Again, we don't need the over 1 at this point. Minus 4 times 3y is 12y over y, but the y's cancel, leaving you with just 12. Okay, so far? Right? Now we're not done. In fact, we know the answer, and this is not it, because we didn't simplify yet, right? Now we have to simplify. The denominator factors as, well, 3 times y squared minus 4, but y squared minus 4 is y minus 2 times y plus 2. So we have 3y times y minus 2 times y plus 2. And again, this is 1 times y plus 2. The y plus 2's cancel, leaving you with a 1 in the numerator and 3y times y minus 2 in the denominator. But I'm missing a y here, aren't I? Yeah, why did I not get the same answer? Where did this y come from? This y here. Yeah, I don't know. There's no y here. I don't know why I put it there, right? This was our denominator. Yep. So, okay. I accidentally inserted a y. So the correct answer is 1 over 3 times y minus 2, not 3y times y minus 2. Okay. So that is the same answer as before. So two good ways of doing this. Just be careful. If you do it by dividing fractions, you have to subtract the two fractions first. Right. Okay, so that's 6b. Okay, so 6c. Again, compound or complex fraction. We have fractions within fractions. So I'm only going to do this one way, right? Notice that this is 1 over 1 here. And the least common denominator here is just the x squared. Right. I'm just copying it down. Right. So what are the denominators? We have a 1, an x, and an x squared. And same x squared here. So remember, the LCD, the least common denominator, uses the biggest exponent, which is the 2, the x squared. Okay. So I'm going to multiply top and bottom by x squared. Right. But only in the numerators. Only in the numerators, right? So when you do that, again, you have to distribute here. This is going to be x squared over 1 minus 9x squared over x squared in the numerator. And then in the denominator, we have 2x squared over x, right? X times 1 is x, plus 6x squared over x squared. Okay, so far? I feel like I should just copy this down. Okay. So at this stage, again, it's a mess, but a lot of things cancel. X squared over x squared is 1. They cancel, right? And this x squared over x squared is also 1. They cancel. Now, x squared over x is not 1, but when you subtract the exponents, 2 minus 1 is 1, so you get x to the 1. Right? Essentially, you can cancel. Well, I don't like doing this, but you can cancel the 2 here because it just becomes a 1. So the numerator here is x squared minus 9. The denominator is 2x plus 6. Okay, so far? Yeah, and it's still not quite done. Even though it is a simple fraction, right? We don't have fractions within fractions anymore. But remember what the directions are. The directions are to simplify. Simplify also means factor and cancel. So we factor the numerator is the usual difference of squares, right? A squared minus b squared. And the denominator, the GCF is 2, so factor out the 2. Now we can see we have a common factor of x plus 3. Cancel those. And we're left with x minus 3 on top and a 2 on the bottom. So, yep, it's just x minus 3 over 2. Squeeze that in there. And I think that's our answer, right? So, yep, I prefer to use, I think this is method 2 here. Again, you can use method 1, but you have to be very careful. You essentially have to subtract these two fractions in the numerator, and you have to add these two fractions in the denominator. It's essentially two problems in one. Okay, not hard, but it's still a lot of work. Is it any easier than this? I don't think so. It's maybe about the same. All right, so that's part C. I wasn't going to do part D. This is already getting to be a long video. So, but all right, let's do it. It's not an easy one, obviously. So we want to simplify 2 over x plus 3 minus 1 over x all over x plus 3 plus x. Right. So I'm going to use the second method here. Right. What we're going to have to do is find the LCD and then multiply top and bottom by that LCD. Again, that's just my preference. If you'd rather use method 1, you could. Right. So remember, this is x over 1. So what's our LCD for all of these denominators, right? Well, we need to include the x in this denominator and the x plus 3. We don't need the 1, but the 1 doesn't usually matter, right? So x times x plus 3 is our denominator, our LCD. So we multiply numerator and denominator by x times x plus 3 over x times x plus 3. Again, be careful, you only do this in the numerator now, right? Because I can cancel these, but then I'm back to square 1. All right. So we're also going to have to distribute. So this is a lot of work here. We're going to get 2x, x plus 3 over x plus 3 minus 1 times x plus 3 over x. And that's just the numerator, right? Now we got to do the denominator. We got x times x plus 3. So x times x is x squared times x plus 3, right? Over x plus 3 times 1. That's just x plus 3. Plus, again, x times x plus 3 is x squared times x plus 3 over 1 times 1, which is 1. So, yeah, this is not pleasant. It looks like a big mess. However, a lot of things simplify here, right? This x plus 3 over x plus 3 is 1. X over x is also 1. And x plus 3 over x plus 3 is also 1. So notice we canceled all the denominators. All the denominators are 1s. So what's left is in the numerator. We have a 2x minus x plus 3. Don't forget the parentheses, right? It's not 2x minus x plus 3. It's actually going to be 2x minus x minus 3, right? We distribute the negative. Right, we'll do that on the next round, right? Here we have x squared plus x squared times x plus 3. And again, we'll have to multiply that out as well. In fact, I guess we'll do that now, right? So x squared plus x cubed plus 3x squared. Okay, 2x minus x is x, so that's just x minus 3. And then we have, be careful, this is 1x squared plus 3x squared is 4x squared. But we also have the x cubed here, right? So I'll put the x cubed in front. And I think that's it. Can we simplify? Well, we can't factor the numerator. It's just x minus 3. We can factor an x squared out of the denominator, leaving you with x plus 4. But it doesn't look like anything cancels. So we're done, right? That's our answer. All right, let's move on to number 7. Okay, so number 7, these are literal equations. These are equations involving a lot of variables, right? A lot of letters, and sometimes numbers as well. So here we want to solve for the variable a. The equation is s equals 2a over r. Yeah, I mean, it doesn't matter what s represents. It represents something called the arc length. A is the area, and r is the radius. It doesn't matter, right? So we can think of this as s over 1 equals 2a over r. And what you have is a proportion, right? So you can just cross multiply, right? You can do 1 times 2a, and that has to equal s times r. Right? So 1 times 2a is just 2a, and that's just s times r. So we're looking for a, just divide by 2. Right? Cancel the 2's. So a is s times r over 2. And we're done. Right? We solve for a. You could, of course, write this as r times s over 2. You can write it as 1/2 times r times s. There's a lot of ways of writing it. I am not picky about that. So yeah, any one of these is fine, right? Or 1/2 SR, same thing. Okay, so yeah, usually it's just solving an equation with fractions, and it usually either means multiplying by the LCD, right? We could have just multiplied both sides by r, right? And we would essentially get the same thing. Right? Divide by 2, So rs over 2 is a. Generally speaking, though, you want to put the a on the left, and you get the same answer that way, too. So a couple ways of doing that. Okay, 7b, solve for h. The formula is w equals 3c over 2h minus b, and I honestly don't know where this formula came from, but it's a formula, right? So w, b, c, and h represent some physical quantities, and you know, it's going to be useful to represent h in terms of the other letters, right, the other variables. So we want to solve for h, right? And again, there's a couple ways of doing this. This is a proportion, right? It's w over 1 equals 3c over 2h minus b. So you can just cross multiply, right? w times 2h minus b is equal to 1 times 3c, right, which is just 3c. I don't need the 1. Oh, you know what? Okay, so at this stage, I would multiply the w, right? w times 2h is 2wh minus w times b, and that's going to equal 1 times 3c, which is just 3c. Right, keep in mind what you're solving for, right? We're solving for, I forgot, h, right? We're solving for this letter here, right? So the w and the b can go on the other side. I can add wb to both sides, right? And this just adds up to 0. Right. So now on the left side, we're left with 2wh. Oops, sorry. I don't know what happened there. Let me try that again. 2wh equals 3c plus wb. Okay, so remember we're solving for h, so just divide by the 2 and the w on both sides. So h is going to be 3c plus wb all over 2w. And there are a lot of ways of writing this. So if you didn't get this answer exactly, just, you know, move around a couple things. It's probably the same thing. Right? You could write this as b times w plus 3c over 2w. That would be fine as well. You could even write this as b over 2 plus 3c over 2w. I would accept that as well. Depending on how you did this, that might be your answer as well. So all of these are fine as well, and including a few others. So right, that's how to solve literal equations. Let's do the hard one. Let's do 7c. Okay, here we're solving for x. The equation is y equals ax plus b over cx minus b. Right. And again, if you're going on to college algebra, this is something you're going to really have to learn how to do. So this is a challenging one, but in some sense, it's not that bad because, again, we have y over 1 equals ax plus b over cx minus b. It's still a proportion, so you can still cross multiply. So we're going to get y times cx minus b, don't forget the parentheses, and that's got to equal 1 times ax plus b. Okay, on the left, let's multiply this out. ycx minus yb equals 1 times ax plus b, oops, x plus b, so we don't need the 1, right? Now remember what we're solving for, right? We're solving for x, but notice there's an x over here as well. So ideally we should get all the terms with x on the same side. Okay, so what I'm going to do is subtract the ax from both sides. So I get ycx minus ax minus yb equals ax plus b. Oh, I'm sorry. We subtracted, right? Ax minus ax is 0. So the left side is just b, right? Yeah, I canceled these. I subtracted them out. You get 0. 0 plus b is b. Okay, now notice that on the left side, right, I have ycx minus ax minus yb, but this yb here, or the minus yb, doesn't have an x in it. So if I want to get x equals, I don't need this term on the left. So I can add that to both sides, right? I'm going to add y times b to both sides, right? Leaving that as 0. So the left side is just ycx minus ax plus 0 equals b plus yb. Okay, so far? Okay, so now comes the tricky part. What do we have on the left side, right? We're trying to get x equals, right? X equals what? Well, we have ycx minus ax. What's the same in both of those? What I'm asking is, what is the greatest common factor? The greatest common factor is just x, right? Just the x. So I can factor out x, and that multiplies yc minus a. And I leave everything on the right the same. Oh, I could factor out a b here. I don't think it's necessary, but if we're in the mood for factoring, let's factor out the b as well. So b times 1 plus y. Right? So on the left side, b is our common factor, greatest common factor. And now we're really almost done, right? Because on the left side, x times yc minus a, we're solving for x, so all we have to do is the opposite of multiply, divide by yc minus a. But do it on both sides. Oh, sorry, yc minus a. Right. And so on the left side, yc minus a over itself is just 1. And there we go, right? So now we have our question mark here. I'll try to erase that if I can. This is not going right here. Okay. Yeah, so x equals what? X equals b times 1 plus y over yc minus a. And that's it. Again, there's a lot of ways of writing this. Right? If you didn't factor out the b in the numerator, you have b plus by over cy minus a. And again, there's a lot of other ways of writing it, but either of these are fine. Okay, so yeah, not an easy one, but a lot of algebra just going back and forth like this. And just keep in mind what you're solving for, right? We're solving for x. So we want to get all the x's on the same side. That's why I subtracted the ax. I got all the x's on the left. And that means you want to get everything else on the right. The minus yb, right? Add that to both sides. And then when you have all the x's on the left, right, it's multiplied by something else. The x is the common factor. Factor out the x, right? The GCF is just x. And then whatever factor this is, just divide by it. So that gets you x and only x on the left. Yeah, so keep in mind that if you got an answer where x is on both sides, like let's say you got x equals by plus 2x over cy minus a or something like that. That's not the answer, and in fact, it doesn't make sense because you can't have the same x on both sides. This is not solved for x, right? So if you get something like this, that's wrong, right? If you're solving for x, you get x on the left and everything else on the right. There should be no x's in this, no x's on the right side. If there is an x on the right side, it's not going to work, okay? It's not going to be the right answer. So yeah, be careful you don't make that mistake. Anyways, that's number 7. These are literal equations, so I hope that helps. And I didn't realize, this is getting to be a very long video, and we're really only halfway done here. We have a lot of other equations and then word problems and then functions. So I'm going to split this up, right? This is going to be part 1. of the review video, and then I'll do part 2, which will be more equations like this, and then a whole bunch of word problems, and then we still have to do relations and functions. So that will also be probably an equally as long video. So sorry to make it this long, but I want to do as many of these as I can to make sure if any of you get stuck on any of these problems that at least this helps a little bit. So that's my goal, is to try to explain this as best as I can. You know, because you have the answers, but sometimes just knowing the answers is not enough to figure out what you did wrong. All right, so again, I'm going through these as best as I can, but they do take a long time. So that'll be it for part 1.